All right, number 45 I think is fairly typical of problems in this section. I'm looking at the structure of the integrand with 1 over a square root of a constant minus a perfect square. I think what we're going to be dealing with here, guys, is the idea of inverse sine of u. If you remember, that derivative is 1 over, and then it's the square root of 1 minus u squared. And of course, there'd be a du dx at the end of all that. I think I can work this one around a little bit to get that to happen. The first thing you have to deal with, this 9 is seriously problematic. We've got to turn that 9 into this 1 right here. And I can do that before I get to my u substitution. So this is going to be the integral of, still a 1 on top. We're going to factor a 9 out from that square root. Now the step I'm going to skip, and in fact I'm going to erase it as soon as I do, is that this becomes the square root of 9, and when we pull that out, that'll leave us with a 1 minus, and this 4 divided by that 9 would be a 4/9 x squared. I'm then going to split the radical and make it the square root of 9 over the square root of all that, and of course the square root of that 9 is a 3. So this is why I'm going to have a 3 right there times the square root of 1 minus, and again that is a 4/9 x squared dx at the end of all that. All right, I better clear myself some space because I think I'm going to need it here. So let me get rid of that and this and all of that. Okay, and we're making progress, but we're still not quite there yet. By the way, though, on the next step, I'm probably going to take this 3 and bring it out in front of that integrand as well. But I think I'm about ready to go ahead and do some u substitution now. I like having the square root of 1 minus a perfect square on the bottom, but I need this 4/9 squared to become u squared. So that's actually how I'm going to set this up. U squared is going to equal 4/9 x squared. So on my next step, let's go ahead and start doing that now. Here's my integral. Again, I said I was going to pull this 3 out. Now remember, guys, that's in the denominator, so that's why there's a 1/3 here. And we have a 1 over a square root of, and this is now a 1 minus, and the 4/9 x squared just gets replaced by a u squared. Okay, cool. The only problem now is my secondary substitution has to replace dx with hopefully du. So let's see where we can go with that. The first thing I'd probably do is take the square root of both sides of this equation. U would now equal a 2/3 x. And then we'll differentiate both sides and get du is equal to a 2/3 dx. Now we wanted just dx by itself, so I'm going to make this now a 3/2 du. We'll multiply both sides by its reciprocal is equal to dx. So I can replace this dx with a 3/2 du. So I'll put the du here, and I'll cram the 3/2 all the way out in front of that. Oh, and I think I got lucky already because that 3 is going to cancel with that 3. That was kind of nice. So that leaves me with a 1/2 out in front, but now take a look at how nice your integrand is, everybody. That right there, 1 over the square root of 1 minus u squared, is an antiderivative of inverse sine of u. I should say, I'm sorry, that was a derivative of inverse sine of u, which makes inverse sine of u an antiderivative of our integrand. It was indefinite, so we'll put a plus c there, and the only thing we have left to do is unsubstitute or resub with this line right here. So it's going to be a 1/2 times the inverse sine of a 2/3 x with a plus c at the end, and that should be our final answer here for problem number 45. Little footnote to my explanation right here. When I went and checked the answer in the solutions manual, I was very surprised that not only did I have the wrong answer, but that's because the problem is totally wrong. So I went back and double checked it. I'm looking at the PDF version of the textbook, everybody, that I scanned for you guys. And this problem, number 45 in the original one, this problem right up here is not what they have in the solutions manual. It's a totally different problem. So then I was worried that I had this problem incorrect, but I did go back and check it in the calculator, and it gave us the exact same answer. So this is the correct answer for this particular problem right over here. So that is the right one for 45.